Hello guys, welcome back. Today we're gonna solve a really special problem that is 3333. Find the original type string version 2. That's the upgrade version of the previous yesterday problem. But yesterday it's just an easy one. Now we got a hard one. A hard one, yeah. Uh, Alice is 10 type specific string on her computer. However, she tends to be clumsy. It may press a key for too long, resulting in the characters being typed multiple times. Um, okay. You're also given a positive integer k. Return the total number of possible original strings that Alex might have intended to type if she were trying to type a string of size at least k. Okay, this method different from the previous problem. That is, we need to create a string the size that must be greater or equal to k. Okay. Mm. And there's one more thing, like the previous one mentions clearly that Alex only typed one key, mistakenly typed one key. But this one, the statement doesn't say about that. So we assume that Alex might type uh, wrongly multiple time. The first one got set the first example, you get A, B, 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 C, C, D, D, and 7. And the original string is like A, right? A. And you can only delete one. So that you can select first A, first B, first C, but D. We got this one, this one, this one, this one. I got 5 solution. Yeah. This one, the original style is A2 and the mean less EK. So it's only one solution that is give the original one. Oh, so there's an edge case why k is less than 1, so it must be 0, right? And this one, let me see why there are 6 AK, A, B, B, and B and K equal 3. So the first one, we can keep the original string and delete the A, delete next A, but you must keep at least one A, right? You can delete all. That's in the requirement. Alice types multiple times doesn't mean I mistakenly tie a new character, so you must keep at least one. And next one, you can delete B, uh, and we got one solution more, that is delete A and B, right? There two A and or delete two B and one A, 1, 2, 3, 4, 5, 6, 7, 8, 8. Yeah, okay, 8, right? You can see I got an A and B here. That's when we can delete A and B at the same time. Um, it's not one character anymore. It can be multiple. All right. So it's really hard, different from the previous one. Let's take an example. C C D D. Okay. First of all, we can only delete continuous substring that's sharing the same character. For example, this, this, and this. We consider each segment is a substring and it's a unit of our problem now. Um, this one we got two, and let's consider this at L. L is like 3, 3, 2, 2. Sum of L I equal to n. All right, and I mean n here. Oh no, length of word, right? And also our problem here is we'll turn to find the sum. Let's call hi is the length of substring I of new string after over. So we got the solution. Got the hi 1 plus 2 plus 2x. Let's call it n. For example, you got this n is for this L is length E4, right? 4 and kind of is the at end. Is must be this, right? At the constraints, the condition we need to satisfy. Okay, and there's one more HI. You you can delete it to 0. You must keep at least 1. So it is condition and it is must less than or equal to the original length, right? You can increase its size, so you remove it, so it can only less than or equal. We got this one. So it turns out from a string problem is it become a numeric problem. All right, but how we show this one, you know, it's really hard, man. Let me think. Hmm. If we count, you can see the constraint case less than 1,000. What we can do? What we can do with this? If we find the solution that less than k, is maybe hard, but how about we found the solution that oh, I see. Yeah. Okay. You got a segment like this, right? This is k. This is k, and you need to find this. This is our solution. Number of ways. How about if we find this one, and then do subtract? I mean, you find on solution, and you find the solution that less than k, and do subtraction. You're gonna got this the same, right? The same. We solve the opposite problem. We can achieve the same result, right? So I gonna convert this one to this problem. Okay, less than k, right? But because k is integer, so we can write this minus one, right? But it's still really hard, man. It's still some tricky. It's still strictly tricky problem. Let me think how to solve this one. Right, got this. Ah, let's try it again. What's next? Hmm. Okay, you can see the length of h here, because each element is at least one. So if n is larger than k minus one, larger or equal to k minus one, so always, anyways, on of the way, on the way, all solution is possible, right? Because each element is at least one. So to sum up, if the length is like k minus one, so it's sum at least k minus one, and it satisfy the condition. No? No. I mean, sorry. It's larger than k. So this condition cannot be satisfied because each element at least one. Sum up it must be at least one, at least k minus one, right? And and if the n larger than k minus one, that means we can satisfy this condition. So we got a 0. No way, right? Else gonna find this L. So we know that else case is 11,000. So we can see can indicate that n is less than 2,002. Oh, it's another limit is proper, is suitable now. It's properly can solve is using an association that nk we can say it's 0,000 is acceptable. We could solve this problem using this one, but how to solve it with this complexity? Hmm. Okay, is then you look at, if you take a closely look at this one, you can see is a knapsack problem. It's a knapsack problem. It's a classic dynamic programming problem on the world. All right, so what we're gonna do here is to DB, right? But the normal DB knapsack problem you have been solving before. It's just about select right, select sum and sum equal to something. But now we got need to find two new condition, that's less than or equal to k. And the second condition is you can select the its value is from a range not exactly a number, but it's from a range a one to a number. So we're gonna got a db solution here. dp I as in number of way formulate the sum as from first a segment. Okay, understandable. And what state can come to I that's a dpis can come from previous one, right? And we can select it. We must select it. That's it. We choose one from the previous, so it's going to be another one. And we can also choose if the length of previous segment, if the length of the current segment is less than two, right? It less than one, right? Two, and so on to the one we can. The last way is select on the original segment. That's the li. Okay, that is so for demonstration. If you don't familiar with dynamic programming, for example, you got a and e and and you gonna find the sum of four, and previously we got the sum of two. So this is three, so you can choose from what, one, two, or three, right? So it can become it's to make the sum is four. You can come from two plus three, got it, or from one plus three, or from three plus one. At box come to this one, two, three. You can choose one B, two B, or three B. One B, two B, or three B. It's on come to the state of the sum of four, right? But this solution gonna cost you O n and number of segments multiple k is the sum, is the final sum we're gonna find, right? And it's gonna the length of what? Why is because we're gonna iterate on some, iterate on the length, right, on the hi here, and we got n. The sum of s is exactly the sum of it is exactly the original string size. So it's gonna achieve this time complexity. Is can it's acceptable, right? So let's think about how to optimize this. You can see this is linear, and we already got this. You can use prefix sum called lex pref from 0 to j. Okay, so just sum it, and actually you can use this. So, Oh, this must be less than, okay, from s minus 1 plus e, so h minus li minus 1. Okay, this is same as the other problem. You're gonna got some you're going to get this one. Just get from this and minus this. This is L R. This is L minus 1. Okay, understandable. Okay, so now we don't need to for a loop like this from s minus li to s minus 1 anymore. So we're gonna remove this. Got it, right? Just implement for. First of all, we need to calculate the segment for. Okay, got it. Okay, for example, A B B C C D D. A two two two. Okay, all right. Right. And then second song vectors. Remember the state. And we also need to vector dp here. Dp, we're gonna call it dp. The style is um, I think we actually I will do an optimization here. Actually, we don't need to cost and multiple n space, only n to just we from to calculate the east row. We need to get the result from the previous row, and actually we you know it's rotate because we care about pivot, so we don't need to stop on the every row. So I'm gonna do something like this. As I mean this total k, k right, k and on a 0, right. Also remember the prefix sum. I'm gonna do is prefix sum here. Same right. All right. Yeah. So there we go. Yes. So, so hmm. remember the I use prefix here. We only care about the actually to calculate the DPR. We need to understand the previous row, but only the previous sum, only not DP. Yeah, so I will store previous sum at the previous. So previous sum of 0. Alright, so it's gonna be on 0 on 1. First of all, we need to for this x from 0 to k, right? dp and dp is. Actually, we're gonna add get some uh, s from s minus l segments I to s minus 1. Okay. Okay. All right. We got it. And we need to recalculate the previous sum. No, say J, please, J. S, okay, is that S, okay. X. All right, I remember to now remember to modulo. I think I think I solved it. The total answers simply you can um to this one. Simply you can choose two of this two way one or two set element. This we can choose one or two this one so gonna got only four way to delete on. Wait a minute. All right, that's right. This one. Okay, just wait a minute. On possible solutions. Wait a minute. Okay. Okay. That's right. You can delete 0, 1, or 2. So got 3. That means equal to the length. For example, this set you got the 3, 3, 3, 3, 3. Okay, all right. This is the number total weight. And sub. Gonna count the sub. And the answer is sub. Sub 4. The sum from 1, 0 to gonna got the sum from 0 to first of all we need to sanity check f here and then minus 1. So we're gonna 0 away. No way. From k minus 1, right? check. Hmm. Right. Check it out. On one. Right. Why? Can come from zero. But it's actually what? But why you don't return anything? Wait, just wait a minute. One A, one but someone like you. There's nothing to lose. Oh, okay. It's not wrong. But wrong is me. Hmm? Oh, all right. So just do this is okay. K is okay. That's right. Just wrongly because I assigned on the DPS to zero. So we need to minus one the solution of not select anything. Oh, nice. Oh my god, I typed, I wrongly clicked submit. I know it's wrong, but use this. I wrongly click it. What now? Oh, it's actually fine. 98? Really? Check. Only one that what we got? Four? This must be one. Hmm. Let's see. And we said this must be the sum. The segment must be exit the queuing length. It's not a exit queuing length. So expand. So the segment is you on the foundation again from this and this. Actually, you can reach this statement. So 4. So 10. What? So we don't need to do this anymore. God, so shit. God. Oh my god, egg case. What the? Tell me. Why you output 0? 1. So you must select it. So it must be 0. Why 0 here? It's, it must be 0, right? Oh no, no. It must be 1. I gonna add more case. Hmm. 0. Oh no. Oh yeah. No, 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 no. Okay, okay. Got. That's mean um if and less than zero, so we minus, so we gonna got total. Sorry, sorry. Just a mistake. Silly mistake. Sorry. Come on. Let God accept it. Yes. Finally. Finally. Yeah, alright, got it. So it perfectly. Can't believe. But why the spec looks so slow? I don't know. But it's acceptable to me. And I'm gonna do some optimization here. This one. Yes. Look like machine really fast, but can be passed at them. Let's check at the first one who's. Yeah, actually you can see it's very similar with my solution. Alright, it's okay. It's very similar, but I don't know why it's faster than me, but okay, it's okay. That's nice day.